2 minus 3 is from it, but I have 97 in it.
Oh, yes. Okay, thank you. I'll talk about it.
Okay. Is there a curve or something?
No. So guys, real quick, I love it. What just happened? If you're having a moral crisis right now, because you should definitely check, every teacher check to add up all the points you lost. If anyone's done that and they lost 20 points, but I gave you a 90, and you're just sitting there like, should I say anything? So for longer tests, normally longer tests for me is like anything over 20 problems or so. To make room for partial credit, I double all the points and then I cut them in half at the end. So I don't have to take off like half a point somewhere or something stupid. You guys semi-understand? The grade on your test is out of 100. Don't freak out. Whenever I say that, somebody's like, this is out of 200. Oh, shit, no. It's always out of 100, the grade that I give you. But to make room for partial credit, I double the points and then cut them in half at the end. Does that semi make sense? So if you're double checking and you count 48 missed points, you should have gotten a 76, because actually you cut it in half, that's 24. You would have gotten a 76. Okay, good. So it's not a curve or anything, it's just double it, so I got to cut it in half at the end. Cool. Okay, so one last thing here. Yeah. One of my least favorite examples, but oh well, it's pretty nice and quick and simple. Come on, little dude. You gonna stay there? Okay. Alright guys, so here I've got a bag. It's got 4 red poker chips, 5 blue poker chips, 2 white poker chips. So you know, we talk about probability, it's going to be cards, it's going to be poker chips, it's going to be this kind of stuff. Now just real quick, if I pick one from this bag, what's the probability that I pick a red poker chip? Red poker chip. Yeah, I'm sorry, you said 4. 4 out of 11. 11, and whatever the hell that is. Alright, that's easy. And blah, blah, blah. But now, what if I pick... Now, I gotta be careful when I say pick 2, because there are a couple ways to pick 2. I could just pick 2 at one time, which is actually different than picking one, putting it back in, and picking another one. So I do the first one, it's called with replacement. And you see why that's important. Because I took a poker chip out and then fed it to my little brother, then what's going to change? The number on the bottom. All your probabilities, every probability changes if I do it without replacement. So let's first do it with replacement. Pick 2 with replacement. What's the probability I get a red and then a blue? Alright, I was very specific in the way I asked this question. What's the key word in there related to probabilities? And. I like it. If I get a red first and drop it back in, will that have any effect on me getting a blue one next? No. So this is what I call independent. Right? Remember that word earlier? Dependent meant if one happens, it changes the probability of the other one. But here, since I'm dropping that first one back in with replacement, it's not going to change the second one. So this is going to be a pure, straight-up multiplication. So I always think about this. What am I doing? How many times am I doing something in this problem? Physically, twice, right? So I got 2 little hangman spots. I got to put a times in the middle because it's and. What's probably the first one is red? 4 out of 11. I drop that back in. What's probably the next one is blue. 5 out of 11. So it's whatever that is. 20 out of 121, which is there's like 33. 30. Is it? I'm way off. No. What's 20 out of 121?
16.5.
All right, I was close. 16.5. Sure. Everybody with me? Please, dear God, don't write 20 out of 11. Right? What's wrong with that? So many things.
The probability is way too high.
Probability is going to be,
100.
well, 20 out of 11 is probably it's going to be greater than 100. That's a huge problem. Oh my God! Don't just leave an answer alone for probability if it's more than 100% or more than 1. At least say something. I know it shouldn't be this, but I can't see where I'm going. Oh, thank God. At least you know it shouldn't be more than 100%. So this really is 20 out of 121, right? Which equals 16.5%, roughly. All right, cool. How are we doing so far? Is that? So what do you think if I picked 3? And I want red and then blue and then white? What would it look like? All right, let's do it. Probability, if I pick 3 with replacement. Probably red, then blue, then white. Well, how many spots do you have now? You're doing physically how many things? 3. So I got 3 spots to fill in. Times, because it's and, isn't it? The word and hides in probability problems, right? Red, then blue, then means red, and then blue, and then white. So it's probably the first one's red. 4 out of 11. It's probably the next one's blue. 5 out of 11. The last one's white. 2 out of 11. So now it's going to be 40 out of 1331. 4 out of 133. Somebody save me for myself.
3%.
Roughly 3%? Sure. I can go with that. What about the probability I pick all reds? Red, red, red. Red round. No red one.
Wait. What's the replacement?
4 over 11 cube.
Yeah, I love it. 4 of 11 times 4 of 11 times 4 of 11, right? You guys see where it's coming from? First one's got to be red. Put it back in. And times. Second one's got to be red. 4 out of 11. Put it back in. And, it's just a little machine, right? So, I love whoever said 4 out of 11 cubed. $64, $20, $40. Save me for myself again. What?
5%.
5% roughly. Like it. How are you guys doing? You see how that problem is not different from this problem in any way, really? I know there's one more thing, but what's the idea behind both of them? You multiply the individual probabilities.
So that question is saying, what is the probability of seeing 3 reds in a row?
Beautiful. And why? What's the most likely thing to get, do you think? Blue, 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 right? So what's the probability of... 5 out of 11 cubed. Do you guys see that? 125 out of 1331. Which would be roughly twice that. It's almost 10% maybe. Is it?
9.3.
Yay, look at me go. Jeff knows math. Sorry, so on one skill. Okay. Show it off every night. That would be the highest probability of any situation you can imagine in this problem, because of course there's the most blues. That makes sense. How are we doing? Is that understood? I can pick 4 poker chips. What would be the only difference? There would be a 4th thing. Or if I wanted 4 reds, it would be 4 over 11 to the 4th power, because it would be 4 of them. So the idea doesn't give a shit how many times you pick stuff out of the bag. It just keeps adding more and more links to this chain, this hangman chain. Maybe. All right, now, what happens if it's without replacement? I don't know.
I'm sorry, what was the question?
So I pick up a poker chip and I drop it back in. Why is that key? If I picked the poker chip and threw it away before I picked the next one, how many are in the bag now? See, the bottoms would change. I couldn't do this kind of thing then, could I? Because each one would be different. Each one would be different. I don't know why. Suddenly had a weird accent there. So if I pick 3 without replacing, so I really want you to understand, this is exactly the same as the O-ring example, right? What did I do? 1% times 1%. 1% chance the first one and 1% the second one. 4 out of 11 chance the first one's red and 5 out of 11 the next one's blue and 2 out of 11 the next one's white. And you can keep going if the question keeps going. Maybe. So now if I pick 3 without replacement, what's the probability I get a red and then a blue and then another blue? Well, let's do white. Let's just see what happens over there. Let's do the same one as that one. Red and then blue and then white. Yeah, so the probability the first one's red, 4 out of 11. Throw it away. So what's probably the next one's blue?
5 out of 10.
Beautiful. Still all 5 blue chips, but now 10 chips. Why did this next one change? Because it depends on what happened on the first one, right? They're dependent now. Of course it makes sense they're dependent because I'm losing chips. Oh, sounds like the normal trip to Vegas. Which you don't do often, think of. And then finally, what's the last one being white?
2 out of 9.
2 out of 9, kick ass.
40 over 9.
This is without replacement. That's why these numbers are going down, because they don't replace the chip. That's why there's now 10. That's why there's now 9. Cool.
4%. 4%.
About 4%. A little bit higher than before. Cool, which makes sense because each of these probably gets a little higher that they'll happen because now there's less not blue. Now there's less not white. So those probabilities got higher than they were before. So the end result is a little bigger than it was. How important is it you understand what I just said? Not very. But if you do, you're a little bit further. All right, what about the probability of red, red, red now? I pick 3 without replacement. Probability of red, red, red. It's probably the first one's red. 4 reds out of 11. Throw that one away. Beautiful. Now the top's got to change because it matches what it was before, right? It's 1 less red and 1 less chip. The next one, 1 less red and 1 less chip. Why did none of these tops change from what they were before? Because I didn't pick a blue. They're still all 5 blues. I didn't pick a white. They're still all 2 whites. Whatever the hell that is. 2%? All right. Maybe.
It goes down to 3 just in case you did pick a red. Because there's 4 out of 11 chances, but what if you pick out a white?
Oh, but see, now what we're doing is, I really want this understood. When you write 4 out of 11 for the probability of a red, does that mean you picked a red? No, that's the chances you picked a red. So I want the chances I picked a red, and if that happened, the chances that I then pick another red. Do you see what I'm saying? So sure, if you play it in, you can pick out a red, white, or blue. But to answer this question, I'm going to set it up. What chance do I have for the first thing to work? And the second one has to also work. So 3/10 of those times, I'll also pick another red. And then 2/9 of those times. So I'm not actually picking, I'm not saying I'm going to definitely pick that number, the color. I'm collecting all the probabilities that all of this happens. So I love your question. That's exactly a good question. I know it's on several people's minds. Hopefully that made sense. Yes?
So the reason on this one is probably the first, of the top numbers to change because you have to pick that number you have to.
Yeah, what did I lose after this step? What do I assume I did after this step, given that I picked a red? So there's still all 5 blues.
And then on this one, you already picked a red. So then
Good. So I really, now watch this. This is the probability I pick a red. That is not the probability I pick a red, is it? Because it's 4 out of 11. That's the probability I pick a red. So what is this? The probability I pick a red given that I already picked a red. Given red on first pick. This one would be the probability I pick a red given that I already picked 2 reds. And so forth and so on. Okay, maybe. So we're actually right on the edge of the formula for AND, and then I'll finally shut the hell up and let you guys work on this sheet. Here's the formula for AND. Oh, and by the way, I've written this down already, right there. This symbol means given. That's what math is a series of shorthand symbols. You just got to know what the English is for it. So isn't this exactly what we did? Probably red times the probability of red given that I picked the red already. So when I do it with replacement, those givens don't change. Given that I picked the red and dropped it back in, probably is red gonna, again, it's going to be the same stupid number, right? So that's why in general this formula makes sense. Hopefully. Alright, I'm going to shut up. There are 2 sides to this. There's the side that says, this side in class. You know, so that side I want you to do. The other side is like a practice mini test. Remember, because the mini test is on Thursday. Tomorrow I'll have the answer key for this, like a normal test. So you can do this at home. I want you to focus on the side that says, do this in class.